Looking at section 3.1, quadratic functions and models. Before we start, since this whole chapter is going to be most of it talking about polynomials, let us see the definition of a polynomial. What is a polynomial function? A polynomial function of degree n, where n is non-negative integer, so that's an important thing, to be non-negative and integer, is given by f of x equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 patterns continues plus a1 x obviously to the first power plus a0, where all these a's, these are coefficients, are all real numbers usually, but it's okay, complex. We know that real numbers are subset of complex numbers. With the first coefficient cannot be 0, because if this is 0, then it cannot be of degree n. This is just this is just telling us there's a number x to that does not, these are not equal. This is just telling me the coefficient of x to the n. This is telling me the coefficient, which is just a number, of x to the n minus 1. And we have them in descending order. It doesn't have to be in descending order, but this is how we define it. So the degree, the power of n of x, has to be a positive or 0. That's what non-negative means. And an integer. It cannot be a fraction. So to get us familiarized with it, I have example 1, and in it you are to decide whether each function defines a polynomial function or not, and if it's yes, what degree. So let's look at the first one. F of x equal to 4x squared minus x plus 1. Well, I don't have all the powers of x are positive integers, so is it a polynomial function? Yes, sure it is. So, and it is, we need to know what degree. The degree, again, is the highest power you see. The highest power is 2. How about f of x is 5x minus 1? That's also a polynomial function, and the degree is the highest power, which is 1. Interesting. F of x equal 2, which is a constant function. Is it also a polynomial? Yes, it is. What's the degree? What's the highest degree? Well, it's as if you have x to the 0, okay? X to the 0 is 1, so yes, it is a polynomial function of degree 0. How about this one? 2x cubed minus x squared plus 3 over x minus 2. Do you think this is a polynomial function? No. How come? Remember, 3 over x is the same as 3 times x to the negative 1. The denominator is a power negative 1. And negative 1 is not non-negative. So that's the reason. How about this one? 2x cubed minus 1/2 x plus 5. Well, this is coefficient. It can be fraction. What about the x squared? The x squared is missing. Is that a problem? Absolutely not. Okay, because if you remember in the definition, all the a's, the coefficient are complex numbers, so 0 is allowed. So as if you have a 0 times x squared. So is it a polynomial function? That's a yes. What degree? What's the highest degree? Is 3. How about this one? I have x to the third, I have x squared, and the square root of x. Think with me. It's a no. How come? Because the square root of x is the same as x to the 1/2 power. And 1/2 is not an integer. Okay, we have to have non-negative integer. How about this? I have a square root of 2 here. Is that okay? Absolutely. X to the 4th plus square root of 2 x to the 3rd minus 3x squared. So that's a coefficient. Again, the coefficient could be any complex number. So is it a polynomial function? Yes. What's the highest degree? Is 4. This is interesting. The 0 function is actually, I have to tell you that it is a polynomial function of no degree. So that's a special one. Okay, so this is what we're going to be studying for 4 sections, polynomial functions. Now today we're concentrating on the quadratic. The quadratic function is a polynomial function of degree 2. Because it can be defined as ax squared plus bx plus c, and that is of course where a, b, and c are complex number, but a cannot be 0, otherwise it won't be quadratic, it will be linear. So what do we want to know from these functions is the graphing, which I'm not going to concentrate too much on because we already covered it in 2.7. But let us look at the summary. This is for you to look at. I'm not going to go over all of it, but we're going to keep it when it is in this format, my quadratic equation. We're going to call it capital F of x is equal to a x minus h squared plus k. Again, that's a quadratic function. But when it is in this format, what's nice about it is we can immediately remember from the techniques, we go h units to the right if it's positive, right? We go to the left if it's negative, meaning, you know, remember the shifting. If we add to the outside, that is, you go up if it's positive, you go down if it's negative. In front is the shrinking and stretching and shrinking. I can't talk. Okay. And that tells me if the absolute value of a is greater than 1, then it is stretching vertically. If it is between 0 and 1, it is shrinking vertically. But also, it tells me if it's positive, that the polynomial opens up, and if it's negative, the polynomial will open down. Now, the most important part, again, in this format, is the minute I have the function written this way, I can immediately tell you that the vertex is h comma k. Because, like we said, it's a quadratic, right? And let me get this scratch paper. Quadratic, so if I have like 3x minus 2 squared plus 3, we looked at it in chapter 2 that you're going to go to the right by 2, up by 3, and then it's a quadratic. Remember, I'm not going to go through the points. So this point is what we're going to be calling the vertex. Okay? And that is the lowest point, and if it opens down, it's going to be the highest point of my graph. But what's important about it is that this is hk, so the vertex is always at hk. Okay, let's look at example 1. Oh, I need to tell you about the axis. Let me say it here. Any parabola is going to have what we call an axis. It's axis of symmetry, but we're going to drop the word symmetry. Okay? This axis is an equation of a line, a vertical line. And remember, since the vertex is at hk, then what is the equation of this vertical line? We just finished that. It's x equal to h. And remember, it has to be an equation of a line, the vertex. I mean, not the vertex, the axis. So for each one of these, we need to give the vertex, the axis, meaning axis of symmetry, domain, and range. What's nice about the domain, look, I filled it out already. What we love about polynomial functions is that the domain is always all real numbers, so not to worry about. So let's look at this. What's the vertex in this function? It is, by looking, look how easy, just 5, 2. Remember, the negative is part of your formula, so you only get HK. All right. What's the axis? It's always x equal, so it has to be an equation of a line, x equal to the h, which is the 5. And now, how would I know the range? Well, we're going to know the range from looking at the coefficient of the first at the first coefficient. If it is positive, that means the parabola opens up, and that means the vertex is the lowest point. If the parabola, so if it opens up, the vertex is the lowest. If it opens down, the vertex is the highest. So if it's opening up, the range is always going to be from whatever k to infinity. So this one is opening up. So what is the range? From the k, including the k, to infinity. Got that? Let's try it again. How about this one? Negative 2, x plus 3 squared minus 2. Where is the vertex? It's at negative 3, comma, negative 2. Didn't leave myself a lot of space. What is the axis? The axis is at x equal negative 3. Again, domain is all real numbers. How about the range? You see that the coefficient is negative, and that means it's opening down, and that means it's from negative infinity, since it's opening down all the way to the highest point, which is the vertex, is negative 2. Okay, I'll let you fill this in on your own. Now, this is beautiful. We saw how nice it is, but imagine you have a problem like this. It's asking you for the vertex and axis, but it's given to you as a quadratic equation, not in the format of the capital F. So how are we gonna do that? Well, we're gonna do it by completing the square. We see how it is always gonna be something we need to know how to do. But this is different than equation. So let's look at how we're gonna complete the square. Okay, so here's what we're gonna do. We're gonna put the x squared and the x, in this case negative 6, so the two terms with the x squared and the x, leave a space to complete the square, and put the 7. Remember, in a function there is no right hand side, okay? It's not like an equation. We cannot move the constant to the right hand side, okay? There is no right hand side. There's only one side in a function. Now, to complete the square, let me take it a different step. To complete the square, you take the coefficient of x, 6, divide by 2. Let me do it here for you. And square, so this is 3 squared, which is 9. So I'm going to add the 9 here. Now, in an equation, we say add 9 to both sides of the equation. Again, there's no two sides. There's only one side. And I added a value. That changes things. So, to undo what I just did is to subtract. So when you add something and subtract it, it's, like adding 0. So now, what do we have? Completing the square, square root of the first, square root of the last, the sign of the middle, squared, minus 2. You'll see now that it's easy to say that the vertex is at 3, negative 2, and the axis is x equal to 3. Okay, so this is how we do by completing the square. So how about, let's do another 1, and we'll do the harder ones in a minute. So now that I explained, we can do this faster. So what do? We put the x squared and the x, leave a space to complete the square. Now you take the coefficient of x, 2, divide by 2 is 1, and square is 1. But if I add 1, I have to subtract 1. So I'm going to end up with x plus 1 squared minus 6. So the vertex is at -1, -6, and the axis is at x equal -1. So let's see the ugliness of what happens when the coefficient of the x squared is not 1. Let me do B, I'll let you do A on your own. Okay, so here's what we're gonna do. Remember, we need those by themselves, but as always, we cannot complete this. The first step in completing the square is to make sure that the coefficient of x squared is 1. So what we're going to do with these two is to take a 2 as a common factor. So when you take out 2, you're dividing. So this is going to be 1/2 x. Leave a space to complete the square. So again, what did we do? We took out 2 as a common factor. Now, you take the coefficient of x, divide by 2, and square, which is 1/2 times 1/2 squared, which is 1/4 squared, which is 1/16. Now we're going to add 1/16. But we're not going to subtract 1/16. And how come? Let's look at what is it that we actually added. What value? We have outside a 2. So what we added is a 2 times 1/16, which is 1/8. So what we actually added is a positive 1/8. So we have to subtract 1/8. So now let's see what we have. We have 2 outside. Completing the square, this is x, square root of the first, square root of the last, the sign of the middle squared, and minus, we need the common denominator, which is the 8. So multiply the 6 by 8. If I left the negative out, that's going to be a problem. So let me keep it positive here. Negative, multiply the 6 by 8, which is 48, minus 1/8. So now what do we have? 2x plus 1/4 squared minus 49/8. Okay, so now let us see the final, or not the final, I mean what they want us to do is is the following. Vertex is at -1/4 and -49/8, and the axis is at x equal -1/4. So I'll let you do the A. Keep an eye on the negative. You have to take the negative out as a common factor, guys. And the the next thing is the vertex formula. It turns out to be that's not the only way we can do things. We can actually find the vertex with the equation without completing the square. How come? From the vertex formula. It says that the vertex of this quadratic function, you can locate it at -b/2a, and the y is just the value of the function at that point. So if I want to actually just before I do the examples of these, just to show you, since we've done one already in completing the square, if I wanted to do this one by this method, let's find let's find what is negative b over 2a. So b is negative 6. So it's negative 6 over 2 times a is 1. So what is that? That is 6 over 2, which is 3. I'm trying to show you both answers. So we know that the h is 3. And how do you find that negative 2? Is by evaluating the function at 3. So this is 3 squared, which is 9, minus 6 times 3, which is 18, plus 7. If you add these are 16 minus 18, which is negative 2. So that's just an easy one I wanted to show you since we already know the answer. But let us work a problem out. I have one that is already worked for you. I got the negative b over 2a, which is negative 1. Then I evaluated the function at negative 1. So let's do the b. Okay. So let's find where h is. H is at negative. B is 12 over 2 times a, which is negative 3. So what is that? That is negative 12 over negative 6, which gives me positive 2. I got the h. How can I find the k? The k is the value of the function at the h. So this is negative 3. 2 squared plus 12 times 2 minus 8. So this is 3 times 4, negative 3 times 4, negative 12, plus 24 minus 8. So this is 12 minus 8, which is 4. So now they want us to find the vertex of the parabola. Oh, and the axis. I'll come back and fix it. So the vertex is at 2, 4, and the axis is x equal to 2. Okay.